In this session, I will introduce you to the NRGsandbox project. If you don't already have the project, simply go on the website under Learning, Demo Project, NRGsandbox, and click here to download the project. Extract the zip file at a convenient location, and then jump to the NRG editor. Open project. In this case, it's on my desktop, NRGsandbox version 1, and I'm going to locate the .npk. I'm going to open it up. Right away, the NRG editor is asking me if I want to unpack the project. I'm going to confirm to make sure that I have read and write access to it. Now, I'm going to expand the library a bit, and I'm going to run you through the directories that are here. At the root, we can find the lib directory that contains all the assets that are common for the project itself, not the sandbox scene. We have the renderer that contains all the different materials and shaders and scripts that will be used by the renderer that have been implemented. And finally, we're having the sandbox directory that contains assets specific to the scene, the sandbox scene. So when it's going to come to a time that you are going to expand and create your own project out of the sandbox, this is basically where you're going to get started. You're going to create a new directory at the root of the sandbox and then copy most of the assets here to get you started. And after that, start setting up and customizing your project. Inside the lib directory, we're having materials. Default material that is a plain material, the one that is assigned on the walls here. And if we push play, the one that is assigned on the 3D cubes that I'm launching, it's in space by either double clicking or pressing space bar. I am having the shader accordingly, and I'm having write depth, as this demo by default implement cascading shadow map. And as you can see here, the first pass that we are going to have into our rendering pipeline, it will write the depth in a depth buffer and then convert that into a cascading shadow. And under the script directory, we have the controller. The controller allows us to move that physics capsule when the application is started, as well as throwing 3D cubes. And when the application is not running, allow us to, inside our viewport, use WASD. If I increase the application time only, I can move around, navigate around, fly around my scene to have a better overview. I am having here a set uniform script that is connected to all materials that are currently inside the NRG sandbox, and it will send over the camera position, the sun direction, the sun color, and will also convert into probe space your object to then be able to receive or cast shadow here. And shadow front is used by the write depth material to only kill the front face and only focus on the back face, which are the ones that are basically casting shadow. These assets here basically are at the root of the lib directory, are the common one that are used also. We're having the cube, that 3D cube, the cube 3D, which is the entity that we're launching in space, a default physics material that it's also applied to that entity, and a sound source that occur when a cube get launched in space. These are the basic shared assets by the sandbox project. I'm going to skip renderer as we're going to go more in detail on the rendering pipeline in a moment, and I'm going to focus on sandbox. At the root of the sandbox, we're having the sandbox scene, and after that, all the material and shaders and script that are connected to these materials. We're having the material for the skybox. Textured is the one for the floor, which is a PBR shader that only take a texture and diffuse a base color and a normal map. We're having the glyph material here and shader that allow us to draw that text using a sign distance field. We're having all the mesh that are currently used in the sandbox scene, including the skybox here. We're having our two texture, our checker base color and our checker normal, and this is a sign distance field that have been generated for the NRG sandbox text that it's splashed here on the wall. And in environment, we're having two cube maps that are used by the PBR shader. That is going to be our radiance and irradiance cube map for PBR lighting calculation. Now, if we jump over to the renderer that have been implemented in the sandbox, and I'm going to go under properties and then scene. These are all the render layer paths that have been created for this specific renderer. So the first one, I'm going to walk you through quickly into each and every one of them. The right depth pass is the first render layer that we're having here that contain all the objects that will cast or receive shadow. And this render layer is also equipped with three probe that is going to take each and every of them will take a different slice of our cascaded shadow map. And we're having the geometry render layer that is gathering basically our normal information, our base color information, everything that will be then passed down that rendering pipeline to do post-processing effect. Worth noticing that we're rendering using multi-sample NC-alias, which lead us to the third render layer, which is Blit, that is going to convert that multi-sample NC-alias into a regular texture attachment that we can then use for post-processing. The next one in line, we're having a bunch of post-processing effects that are all built basically the same way. We're having a camera that is rendering to texture if I select, same for the geometry. And we're having here, if I enable the camera properties, all of them are equipped with render to texture functionality that allow us to use a frame buffer. And for each of these post-processing effect, will output offline a one or multiple texture that will be sent down to the rendering pipeline. So we're having screen space ambient occlusion, we're having a blur of that texture generated, bloom blur, screen space reflection, screen space reflection blur, and now we're jumping then to composite. Composite will take all the results of the previous pass and compose the final image, but as you can see, we're still in linear space here. We're going to convert into sRGB later on. We are going to then use the composite output and pass it down to the motion blur that have been calculated in the geometry pass. And if I stop increasing the time and I move my mouse quickly and stop, you can see the motion blur at work here. And as I continue updating, you can see that now it goes back and blend with the actual output. And we have now next the depth of field that is going to allow us to put more focus on near object and blur objects that are more far away. So when you want to, we are going to handle that in another session, but basically what you have to understand is if you want an object to reside in the sandbox, it have to be on at least one or two render layer. If you want that object to cast shadow, it will needs to be part of the right depth render layer and geometry. So like that, the renderer can grab the information, pass it down to finally arrive at the final result. Worth mentioning that for all these post-processing effects, you have access to a bunch of tweaking knobs. If I go and select an example, screen space ambient occlusion under properties and material, shaders, and in user variable, I got a bunch of tweak that I can do to increase the quality and so on. Same goes for all for the bloom, the screen space reflection, and all the way down to depth of field. And the final one, which is the result, that as you notice does not use a camera. As a final result, what we're doing is basically just drawing on the OpenGL back buffer, and the material used for the result will take the final depth of field result and basically draw it on a 2D quad. If we pull off this material result, we also have a bunch of tuning knobs that allow us to modify, like in this example, the vignette, and we can also change the gamma to get a better image of our final composite. In the next session, I will show you how to set up your object properly. We're going to start slowly and then end up with a full customization of an object that will be part of the sandbox.